Hi. Let's discuss about subnetting. So what is subnetting? So subnetting is nothing but it's the process of dividing a single network into multiple networks. Okay. So it means so here we are having 32 bits, right, in IPv4 address. Okay. So these are the 32
Yeah,
bits, right? So 8
yes. 8,
and 16, 24 and total
24,
32 bits. Okay,
32.
so here we have for class A, first 8 bits are related to the network, and for class B 16 bits related to the network, and class C 24 bits related to the network portion. Okay, so here converting these host bits into network portion. Suppose consider that it's a class A network. Okay, so for class A what we have, all ones, right? 6, 7, 8 ones. Okay, remaining 0, 0, 0, 0, 4, 5, 6, 7. Okay, so like that zeros we have, right? So converting of these zeros into ones is called subnetting. Okay, so why we have to convert all these things will discuss. Okay, so here the process of dividing a network into multiple networks. Okay, suppose in our earlier class, we discussed about suppose we have HR subnet. They need only 50 people. Okay, but in the slash class full network, what we have, if you take slash 24, we have almost 250 plus IPs. Okay, so here we are assigning only 50 IP addresses. 200 IPs are wasting, right? Okay, so that's why what we are doing, we are dividing these 250 plus IP addresses into multiple subnets. Okay, so I mean based on the requirement, suppose HR team requires 50 subnets, 50 IP addresses, so 50. Okay, so based on the requirement, suppose here we require 100 IPs. Okay, so here again 50 IPs we require. So based on the requirement, we'll divide a slash 24 subnet into multiple subnets. Okay, is called subnetting. Okay, so here
Okay.
what we are doing, if you convert, okay, we have to increase the host network portion, right? So suppose we are dividing a network into smaller networks. So smaller networks, so while dividing the smaller networks, host portions will be converted to the network portion. Okay, so here why we are doing the subnetting, to remove, to avoid the wastage of these IP
Wastage of
addresses, we are going for subnetting. So here we have subnetting, in two ways we can perform the subnetting: FLSM and VLSM. FLSM stands for fixed length subnet mask, and VLSM stands for variable length subnet mask.
variable.
So what is this FLSM and VLSM? Suppose here we have so as an example, okay, 256. Okay, so
Okay.
256, 256 IP address will be there, but the last one is 255 only. So if you can
255.
consider from 0 to 255, in total 256, right?
255
256 we
address.
have. Okay, so dividing these 256 IP addresses to each and equal subnets, that is 128, 128. So fixed, right? So we are dividing one
Yeah.
network into multiple networks with a fixed number. Okay, that is called
Yeah.
VLSM, sorry, FLSM, fixed length. Okay, suppose if you can divide this 256 into four subnets also, four networks also,
Yeah.
64,
64, 64,
64,
64.
64, 64. So though here if you are dividing in detail, 32,
32,
32,
32.
32, 32. So here dividing a network into multiple networks with a fixed in number, that is called
Yeah.
fixed length subnet mask.
Excellent
Okay,
subnet mask.
yeah, so here in case of variable in subnet mask, what happened? Okay, so here we have 256. Okay, so here we are dividing this into 128, 64 and 64.
54.
So the length is different, right? Here
As per the requirement, we are dividing.
as per the requirements we have to divide. Okay, so we'll discuss about that, but for now, what is FLSM? We are dividing a
Excellent
subnet
subnet
into
mask.
multiple subnets with a fixed length, is called fixed length subnet mask, and variable length subnet mask. Okay, so let's,
Okay.
if you can see here, we have a slash 24 network. Okay, so in slash 24, how many we have? In slash 24, how many we have? 256 IP addresses, right? So here
Yes.
among these 256 IP addresses, what these guys are doing, they are dividing this, slash 24 into slash 27. Okay, slash 27 means these 256, what they are doing, they are dividing into 32 IP addresses. Okay, slash 27 means 32 IP addresses will come. I'll show you how it is. Okay, for now, if you can observe, Okay, so this is a requirement. Okay,
Okay.
this is a requirement. So we have only one subnet. So we have /24 network. So we have to assign this /24 network to different teams. Consider that team A, team B, C, D, E, and F. So these many teams are there. Okay, so we have to divide this network into multiple networks for A, B, C, D, E, and F. Okay, so we have two
Yeah.
kinds of subnetting, right? FLSM and VLSM.
FLSM and
So
VLSM.
in case of FLSM, what we are doing, we are dividing the subnet into multiple /27 subnets. Okay, so it's a constant
Okay.
one. Though you require 4, we are giving /27 only. Here we require /25 sub IPs we need. Okay, but we are doing with /27 only. So if you can observe here, we are dividing this network into in a fixed manner. Okay, though it's required
Okay.
or not required doesn't matter. Okay, but we are dividing that into multiple networks with a similar number of IP addresses or the same number of IP addresses which is available. Okay, so in case of /27, what happens? We have 32 IP addresses. Okay, so how
Okay.
it is, I'll tell you. So here, 24 bits is network. Okay, and 8 bits are related to host, right? Okay,
Yeah.
so here what we are doing, suppose /27, right? /24, and these are zeros, right? So here we have 1, 2, 3, 4, 5, 6, 7, 8. So these 3 bits are converting to network. Okay, it means 27 now. How many
27.
host portions we have remaining?
5.
5 is there, right? So 2 power 5, how much? 2 power 5? Because it's in
2.
it is in binary. Okay, so if you want to
Yeah. Okay.
convert to decimal into 2, like we have to do, right? 2 power of these things, right? So
Uh-huh.
2 power 5 is equal to 32 now.
32.
So why they are doing /27? Because they need to assign for one network 25 IP addresses they need to assign. For another network they have to assign 30 IP addresses. Okay, so
Okay.
if they want to move this network like host portion to the network, how many they need? They only 3 they have taken. Why? Because 2 power 5 is equal to 32. Okay, if you have 32 IP addresses, we can assign to everyone, right? So we can satisfy every team by assigning the IP addresses. Okay, what is the nearest number up to power will be divided into as a host portion. Okay, so here they need 30 and
Okay.
25. That's why they have taken as /27. And though here we have only 6 IP addresses, right? Here they need only
Okay.
6 IP addresses, but though they are assigning /27 only because of FLSM. So here what's
Mm-hmm.
happening again? See, we are from class full, we are wasting IP addresses. Again in classless also we are wasting IP addresses because we need only 6 IPs, but we are assigning with 32. Okay, so
Okay.
that's why we have VLSM concept coming into the picture. Okay, so in case of VLSM, what they are doing, again we have /24 network. They need, this is the requirement of them. Okay, so here,
Okay.
how many IPs they need? 25 IPs they need.
25.
Okay, so if you want to assign 25 IP addresses, what is the 2 power which is related to the 25? 2 powers are, 2, 4, 2 power, 2 power, 2 power 2, 4, 2 power 3, 8.
8.
Okay, 2
16.
power 16, 32, 64, 128, it goes on, right? So here
Yeah.
related to 25, what is nearby here? Like, let me mention like this. Okay, 2 power 1, 2 power 2, 2 power 3,
2,
2
3,
power
2,
4,
2,
2 power 5,
2,
2
4,
power 6,
5,
2 power 7, and goes on. Okay, so near to 25, what is the number we have? 32, right?
2.
Okay, so 32,
Yeah.
how many bits it is? 5 bits, right? So
5.
that's
Yeah.
why, like what they are doing, these 5 bits as the host portion. Okay, so here we have till 24 bits as a network and 8 bits are host, right? So only 5 they are taking as a host bits. Remaining 3 it will be added to the network. That's why we have /27 here.
Okay.
Okay, clear?
Yes.
Okay, and here they need only 6 IPs. Okay, what is 6 nearby?
8. 2 power 3.
2 port 3, right? So how many host bits we have? 3 host bits. Okay, plus 5 is equal to 8, right? So here 24 is
Yeah.
there, plus 5 plus 3 is equal to 32, right? So here
Mm.
what they are doing, they are adding this network portion to the original network portion, that is /24. So we have /29 here.
Mm-hmm.
So here how many they need?
10.
So 10 is nearby 16, right?
2 power 3.
No, nearby means it should be more than.
Oh, okay, okay. More than, yeah, okay.
Because if you have, if you need 10 IP addresses, okay. But if you take only 8 for
It is
two,
less than that. Yeah, yes.
so we need to assign the IP addresses to them, right? So
Yeah, okay.
what is the nearby value? So that is 16, right? So it should be more than.
It
I
should
can
be
say
greater than that, but
greater
not
than
should be less.
greater than to the number requirement, we can say. Okay.
Yeah,
So
okay.
our requirement is 10. What is the nearby the 2 power series? That is 16, right? So here
16,
4.
yes.
So by default we have 24 is there, plus how many host portion? 4. 32 it will come. So how many we need here? 4, right? So they're adding
4.
this 4 as the network and remaining as host portion. Okay, that is about VLSM. Is it clear now?
Yes.
So this is about FLSM and VLSM concept.
Yes.
Okay, let's go further. Okay, so here subnetting is can be done based on the requirement. Okay, so here how many number of hosts we need? Okay, suppose we need some 64 hosts. Based on the requirement only, we are dividing a network into multiple networks, right? So that is called subnetting. Okay, and how many number of networks also we need? Okay, so let's try to calculate these things. Okay, so here we have like a requirement of host. Okay, so here we are doing what is our requirement? Suppose our requirement is some 80 IP addresses. Okay, so how many number
Okay.
of host bits? Okay, so here we are discussing, right? So depends on
2
the
power of host
power only we
bits.
are calculating the subnet masks, right? So here
Yeah, yeah.
2 power of how many host bits if you can take, we will be able to get the requirement. Okay, so that's
Okay.
related to requirement of host. And how many number of networks? 2 power of this host bits is equal to requirement. Okay, suppose if we need some 6 networks. Okay, so
Okay.
2 power of host bits is greater than or equal to 6. So how many we have here? We need 3, right? 3 is
Mhm.
greater than or equal to 6 now.
Yeah.
So 8 is greater than or equal to 6. Okay, so like how we can be able to calculate these things. So let's go with some example. Okay,
Okay.
so let's go with like a fixed length subnet mask. Okay, so we are dividing this network into multiple networks. So what they are doing, they want 40 hosts.
You require fast hold
40 hosts by using class C, they mentioned.
class C
Okay,
address.
so for class C, what is that? First 3 bits, first 3
First 3 bits are network addresses, the
network
last one is the
and
host
last
address.
is host address. Okay, so here how many host bits we require, we don't know, right?
Yes.
Let's try to calculate that. Okay, so what is the formula? Formula in the sense just kind of formula, but we calculated earlier also. How many host bits? 2 power of host bits
The power of
minus 2 is greater than or equal to requirement. Why we have minus 2 here? So we have like network address, broadcast address, and remaining valid IP addresses, right?
valid IP is.
So valid IP address is the requirement here. Okay, so that's why we
Okay.
are doing network address and broadcast address is
Broadcast
minus here.
address we are okay.
Okay, that is the formula. Okay, so here what is the
Okay.
formula? 2 power of h minus 2 is greater than or equal
Minus
to
2 is greater than
requirement.
or equal to
What is the
requirement.
requirement?
40.
40.
40.
So let's make like power tables here. Okay, 2 power 1 1, 2 power 2 4, 2 power 3 8, 2 power
8,
4 16,
16,
2 power 5 32, 2 power
32,
6 64,
64.
2 power 7 128, right? So here what is
Yeah.
our requirement? 40. So we have to think about what is the greater than value of like more value than 40, which is nearby
Requirement. For 6.
64, right?
Yeah.
So 2 power for 64 if you need, what is the power? Host bit says
6
6. 2 power 6 is minus
minus
2 is greater than or equal to 40. Okay,
40.
so here how many we are having? 64
32 greater than
minus
or
2 is greater than or equal to 40. 62 is greater than or equal to 40. So we are dividing a network into multiple networks here by using like 6 host portion. Okay, so here 62 is there, so we need only 40. So here remaining 22 IP addresses are wasting, right? That's fine. So instead of wasting hundreds of IP addresses, we are wasting only 20, right? That's not a problem
Yeah,
because the
okay.
requirement is 40 only. So here, so how many host bits here we need? How many host
We
bits?
need 40.
No, no, requirement is 40 IP addresses. Host bits I'm asking.
Yeah, okay.
6,
8
right?
minus 2, 2.
See, host bits I'm telling. 2 power of 6 is greater than or equal to our requirement, right? So what is the host portion here? We are taking 6 as the host portion, right?
Yeah, yes. The remaining 2, I'm saying.
Yeah, yeah, then that's fine. Leave about remaining 2. I'm just asking about host bits itself. So
Yeah,
we
okay,
have taken
6.
6 host bytes. Okay. And here, so converted network bits we need to convert. Okay. So how we to calculate that? Okay. So total number of host bits in class C is 8, right?
Yeah,
So total number of host bits is 8. How many we require? Only 6.
6.
Okay. So is equal to 2. So converted network bits is equal to 2 here.
2.
So in the last example I mentioned, like till dash 24 is there, and here 8 bits is there. Okay. So only 6
Yeah,
it is related to host here, and remaining 2 we are considering into network. That is
network.
24 plus 2, 26, right? So in the similar
Yeah,
fashion, we are calculating by using the formula. That's it.
okay.
Okay. So here total number of converted bits is equal to 2, right? And only converted bits is okay. So total is equal to, so by default for class C, how many? 24, right? 24
Yeah,
plus converted network bits 2.
2.
So total is equal to 26.
26.
So here we are dividing this network into 4 portions. How many network? I'll tell you. Okay. So here 192, 168, 1.0/26. If we can take, we'll get around 60 IP addresses. We can assign to 40 members. Okay. Is it clear?
Okay.
Okay.
Yes.
And how many addresses so will come from one network? 2 power of host bytes minus 2 is equal to 60. It is coming now.
Hmm.
62. See here, same thing we calculated, right? 2 power of host bits. So what is 2 power of host bit? 2 power of 6 minus 2 is
6.
equal to 62.
64 minus 2.
64 minus
Yeah.
2, 62, right? So these
Yes.
many IP addresses we are getting. That's what it means. So
Okay.
in /26 network, okay, we are having total 62 valid IP
62
addresses.
of the meters.
That is what it means. Okay. And
Okay.
how many number of subnets will get from this here? Okay. So
Okay.
2 power of n. 2 power of n means like what is the converted bits here? 2, right? Converted
2.
network bits. 8 host bits, total host bits minus network host bits. That is 2, right? 2 power of 2
Yeah.
and 4. So
4.
we can divide this /24 network into 4 subnets as FLSM. That is, let me tell you here. Okay. So 192, 168, 1.0/26. Okay. Again, plus 62 IP addresses, right? So it will come 192, 168, 1.63 till it will come na in case of this one.
Mm-hmm.
And then next one is 192, 168, 1.64/26. So till here it will come here till 127 it will come. Okay.
Okay.
Again from 128 to 223. Again 224 to 255. Okay. So we are dividing this /24 into 4/26 subnets. Okay. Let me show you what are the subnets. Like here I'll write it. Okay. So here we can divide this subnet into, like I think we have this here. Okay. So here like we are dividing these subnets into 192, 168, 1.02, 192, 168, 1.63. That is 192, 168, 1.0/26 network. Okay. And again 4 we can divide, right? Like if you can see here, total subnets how many we are coming, we are getting 4, right? So
Yeah, yes.
so we are dividing like that only. So next one is 192, 168, 1 dot. Next what is the next IP address? 64 na.
64.
64 to plus 62. It means 192, 168, 1.127. This subnet we can say then 192, 168, 1 dot whatever it is there here. Okay. 64/26. Okay. And again 192, 168, 1.128 to 192, 168, 1.191. Okay, so what is the subnet here? 192.168 1.128/26. So here we are just doing +1, that's it. Okay,
Okay.
again 192.168 1.192 to 192.168.1.255. So here that is to 168 1.192/26. So we are dividing this /24 into 4/26 networks.
Yeah, okay.
So here the /26 is remains fixed one, right? So that's why we are
Yes.
telling it as FLSM, fixed length subnet mask.
Okay.
Okay. So if you observe here, okay, from 1 to 0, how many we have? 256, right? So we have divided this 256 into 4. That is 64 IP, 64, 64, 64. So here we are doing -2 because we are giving 1 to network, 1 to broadcast. So we have valid IP address are 62 in each
62.
network. Okay, so our requirement is 40 hosts using the class C network address. So it is fulfilled.
Okay.
This is how we do, like network calculations.
Okay.
So here, if we observe, we haven't changed any network portion. Only host portion it is changing.
Yeah, yes.
Okay.
Okay.
So let's go further with another requirement. Okay. So here we have, they're asking 500 hosts using class B.
Okay.
Okay. So here class B is nothing but first two host network
First
and
two.
other two net host, right?
Oh,
So let's have the 2 powers. Okay. 2 power 1, 2 power 2, 4, 2 power 3,
4,
8, 2 power 4, 16, 2 power 5, 32,
32,
2 power 6, 64, 2 power 7, 128,
28,
2 power 10, 256. Okay. Sorry, 2 power 8, right? It is 2 power 8, 2 power 9, 512. Okay. 2 power 10, 1024. Okay. So here, what's the requirement? 500 hosts. Okay.
500.
So let's consider that. Okay. So here, just keep it in mind for class B, first 16 bits are network and last 16 bits are host.
Host.
So here, host bits, we need to consider what is the host bit formula? 2 power h minus
2
2
power
greater
h
than or
minus
equal
2.
to our requirement, right? So here, what is our requirement? 2 power h minus 2 greater than or equal to 500. Okay. So what is the h power here? H here,
9.
so nearby 9, right? So
Yeah.
host portion is equal to 9. Okay. So here 512, 512 minus 2 greater than or equal
Minus
to
2
500.
greater than
So
equal to
510 is
500.
greater than or equal to, so we can take this host portion. Okay. So number of host bits are 9.
9.
Okay. Now here, total, what is the default network bits here? 16. And default host bits are
16.
16. Okay. So what is the total host bits here? 16 minus how many we require? Only 9. Okay. So 16 minus 9, 7.
7.
Okay. So by default, we have, the network bits as 16. Okay. Plus, what is the converted network bits? How many we have converted? So 7 we have, right?
7.
So /23 it is.
23.
So what does it mean? So here we have, 16 as the host network base, 16 as the host bits. Okay. So here among 16, we require only 9 bits as the host portion. Remaining 7, whatever, like total 16, right? Only 9 we are taking
Yes.
for host. So remaining 7 will be there. So we are adding that 7 into the network portion. That is called total number of network bits. That is 23. Okay.
Okay.
So what we are doing, so we have /23 here. So we are dividing this network into a subnet /16 into different subnet where we need to have 500 hosts. Okay. So now how hosts per subnet, how many hosts we are getting? Okay. So we have taken /23 it is. How many hosts we are getting? 2 power of
9
9
minus 2.
minus 2. Why we are doing -2? We are removing the network address and broadcast address. Okay. So total we are having 510 hosts per subnet.
Okay.
Okay. And how many subnets we can convert this /16 into? We have to convert into /23 right now.
Yes.
Correct? So we have to
Yes.
convert this slash 16 into different slash 23 networks. Okay. How many slash
Okay.
23 networks will come? 2 power of n converter bits, 2 power of
9.
9.
512.
Okay. So 512. Okay.
Okay.
1 second. 2 power of n. Yeah, that's fine. Okay. And 2
2
power
power of
7,
7.
right?
7.
7.
7.
That's what I was thinking. 7. Yeah.
Yeah.
2 power 7, how much?
2 power 7.
128.
128.
128. Okay. And customize subnet mask, I'll tell you here. Okay. How to calculate the subnet mask. So is it clear so far?
Yes.
So here what we are doing, let me tell you. So we are dividing this network into 172.16.0.0./23. Okay. 23 how we got? This is how we got 23 here. Okay. And in case of 23 again, so here the starting IP address we need like how it will come, I'll show you. 172.16.0.1 to 172.16.1.255. Okay,
Okay.
this is how we will get it. So here we have how many? We have 255. Okay, again here 255. 512 is coming now.
Yes.
So that's why we have the ranging. Okay, and next subnet is 172.16. Okay, one is done. Now 2.0/23. So here 2.1 to 3.255. So 510 is
Yeah.
coming here again. Okay,
Yes.
so the requirement is 500 hosts per network by using the class B. So here we are not changing, any, what I can say, this the network bits, right? We are changing only host bits,
Yes.
depends on our requirement. This is how we can calculate the subnets. Whatever things they're given, this is the process we need to follow.
Okay.
Okay, and one more thing, we have subnet mask. Okay, so how to calculate the subnet mask? So here, if you observe, no, here 255 was showing now. So here for for class A, class B, class C. Okay, so let's see, like how to calculate the subnet mask here in case of our requirements. What we discussed here. Okay, so here we have divided this /24 into multiple /26 subnets. Okay, so here if you want to calculate that, by default for class C, what is the subnet mask? By default for class C, 255.255.255.0.
255.0.
Okay, for class first 24, but we are taking additional 2, right? Plus 2.
Yes.
So we have to add that here. Okay, so if you want to remember easily, okay, for /26, so here like it will be like this. Okay, so for class C, all the first 24 bits are the network portion, that is V111 kept. Okay, the similar fashion here for among 8 bits 1100054567. Okay, this is how it would be. Okay, and we
Okay.
have to calculate how much the value it is, 2 power of these things. Okay, so in a simple, if you want to remember /26, okay, so 128 plus 92, 64. Okay, so here 64, right? 256 minus 64. How much it is? 9.
192.
Okay, so for /26 subnet, what is the subnet mask now? 255.255.255.192.
92.
Okay, suppose we divided, let's consider done this. Okay, so we have /27 now. Okay, so /27, what is the subnet mask? 24 plus it is, right?
Yeah.
24 plus 3. So first 3 are 255.255.255.255, and last one we need to calculate. 27 means how many, like how many IP addresses if you want to cover means. Okay, so in a simple way, if you want to calculate in general, okay, so 32 minus 27, how much? 5, right?
5.
32 is total.
Yes.
Okay,
32
32
minus 5
minus
is
the subnet,
5.
okay, that is 5.
Okay.
That is equal to 5. So 2 power of 5, how much?
64.
32. 32.
So, okay.
So 256 minus 32, how much? 4, 2, 2.
224.
224. So for slash 27, the subnet mask is 255.255.255.224.
224.
Okay, is it
Okay.
clear?
Yes.
So we are like subtracting the subnet from the 32, whatever we are getting the number 2 power of, we'll get one number minus 32. So we are doing that minus from 256. Okay, so in the similar fashion, let's see here. Okay, so by default for class B, what the subnet mask 255.255.
If I
Okay,
dot
0.0 in general for slash 16. But here our network is
20,
slash 23, right? So let's calculate that.
23 minus
So
16.
yeah, first step is 32 minus 23. How much?
23.
9.
9.
Okay, now next step 2 power 9.
120.
One second. So not this one. Okay, like a 24 nearby value we have to take. Sorry. Okay, so here like so here why we have taken 32, because 8, 16, 24, 32, right? So this is 24
Yes.
between this one, right? So we have to take the last nearby one. Okay, so
Okay.
here we have 32 only, that's why we have taken 32. Okay,
Mhm.
so in case of like this one, okay, so what is the nearby value? 8, 16,
8,
24, 32,
16.
right? So here 16 plus 24 na.
Yeah.
So 24 minus how many bits we are taking? How many host
20,
portion? 23, right?
23.
23 na, this subnet is
Yes. Yes.
23.
23.
That is 1. Okay, so 2
Okay.
power of 1,
2.
2. Next 256 minus 2, 254.
54.
So here we are coming into the third one, right? So here the subnet mask is 255.255.254.254.0. Okay, so for any slash 23, if we take, this is the default subnet mask. Suppose
Okay.
let's go with some example. Okay, for slash 20, let's take a different one, slash 28. Okay, for slash 28, first step is the nearby value is 32,
2
right?
minus
32
28.
minus 28, 4,
4.
2 power 4,
2 power 4.
16.
16.
Next, 256 minus 16,
56 minus 16.
240. So
240.
subnet mask is
40.
255.255.255.240. Okay,
Okay.
clear?
Yeah.
Okay, so let's take another example. Okay, suppose we take like slash 21. Okay, slash 21 is nearby. 24 minus
24.
21, 3,
3.
2 power
2
3,
power 3.
8.
8.
Okay, so
256
256
minus 8.
minus 8, 248.
248.
So for slash 21, the subnet mask is 255.255.248.0.
0.
This is how we can calculate, like the subnet mask, and how we can do subnetting. Okay,
Yeah.
so
Okay.
so here the valid IP addresses are 0 is there, so 255 is there now here. So 1.0.1 to 1.254 is the valid IP addresses. Okay,
Okay.
0.0 is the network address, 1.255 is the broadcast address. Whatever the addresses which are between, those are called valid IP addresses.
Okay.
And next one we have like VLSM, that is a variable length subnet mask.
Variable
So
length subnet
we
mask.
can use efficiently. So here last time what we did in case of FLSM, this slash 24 will be divided into 4 slash 26.
Yeah.
Okay, but here by using VLSM we can like divide that into a different number. Okay, so it is efficiently used. Okay, so here for slash 26, what is the starting IP address?
192.
192.168.1.0 is the network address. 192.168. If you can calculate, okay. So 64 IPs it will come here, na. 2 power of 32 minus 26, how much? 6, right? 2 power of 6 minus 2 is equal to greater than or equal to requirement, na. So here 62 valid IPs we are getting. Okay. So
Yes.
1.63 is the broadcast
Yeah.
network. Remaining are the valid IP addresses. So we know how to calculate the subnet mask for slash 26 and 2728. Okay. This
Yeah,
is how,
okay.
this is what it is about, what is subnetting, what is fixed length subnet mask, what is the variable length subnet mask, how we can do the subnetting, all these things.
Okay.
Okay, and what is classful address and classless addresses we discussed. Okay, so yeah, that's all from my end.
Yeah, okay.
Is everything clear or any doubts? You can ask me.
Yeah, clear, but I have like clumsiness. So I need
See,
to sit and I
for,
need to
yeah,
say.
for the first time, it will be like that only.
Yeah.
Okay, even for me.
Hmm.
So if you can practice, then only
Yeah, yes, yes.
you'll be able to understand clearly.
Yeah, sure.
Okay.
Hmm.
So next class we'll discuss about OSI model.
Okay.
Okay. Thank you.
Thanks, Ash.
1 second.